We are 10 seconds to live.
Okay.
Yeah, yeah, we are good.
Just 1 second. I hope you can see the screen now. Yeah, we are live,
Yes,
right?
it.
Okay. Yeah. So, welcome to everybody. So we are, yeah. So, this is the seventh session of Certified Meshery Contributor Study Group. My name is Kavita, and here's my co-host Ronak, also along with me to take the session today. In the previous three sessions, in the previous 6 sessions, we had actually covered all the initial three modules, Meshery CTL models, and then uh, these sessions, Meshery CTL models, and then we are actually right now going to the server module. And we had also covered extensibility before going to the Meshery models earlier. So yeah, so this is the page in which you can actually go and then enroll for the certified Meshery contributor for the uninitiated, and you have self-paced trainings for each of them. These are the 5 units. We covered all these three, and this is actually the one which we are actually going to contribute see for today. And then I have actually mentioned the topics here. And there are two things which comes to when it comes to measuring server unit. There are two different things that we have to actually cover. First one is actually the measuring server contribution itself. Um, and then how second one is actually related to the measure CI. Um, so built-in release CI and the self-paced training, what we see here, the CI/CD pipelines slides, we would be actually using them in the next session. We decided not to cover everything in one session itself because we don't want the attendees to feel overwhelmed with what we are actually covering. So, without much further ado, we will actually go for um, the topic. So, Measure server. Um, so, as I have actually told earlier in the previous calls, in Meshery CTL and Meshery UI actually sends requests to the Meshery server. From there, it actually goes to through the adapters and then finally to the providers for cloud native application management. Um, so in case of Meshery server, first we would actually look into what exactly is the source code looks like. For people who have attended Meshery CTL's um, uh, training or who have viewed that would be kind of knowing where exactly the code base would be. So there is this um, Meshery/Meshery. This is the GitHub location for Meshery/Meshery, where you have all the um, all the documentation related. This is the place where you had actually created the newcomers meeting introduction. If you remember correctly, in the previous call, just before this one, you might have actually created your meeting minutes as a part of the meeting minutes, your introduction over there. Install scripts are actually here. Meshery CTL actually deals with the Meshery command line interface, which you have policies separate for the Meshery policies. Provider UI, you have this one. This is the server code, which is actually the subject for today, and this is the UI. And if you look at the Makefire, as we had seen in our earlier places, we have something called server. So yeah, the server, make server, if you actually run that, you would actually, as you see, it goes into the server CMD where the main.go actually lies, and the error.go, and then a couple of few other files also lies in that place. And then see, this is what you have there. So it actually takes up the environment variables according to what you are passing. Otherwise, it actually takes the default what is actually defined there. And then go run main.go error.go. That's as simple as that. Um, what you have in server is actually pretty much the same, with the different change that dependency check is also there. So this target is actually being called, sorry, um, build server. Yeah, build server is actually just a compilation. It's just the building. It doesn't run using the go run main.go, which you saw earlier. Yeah. So there's a dependency check, a separate in make target is there that you can actually refer for yourself. So coming back to Meshery, contribution to Meshery. So there are actually three commands that you have to actually run for running the Meshery server. First one is actually like you call the make UI setup and make UI build. Make UI setup. So it actually just goes into UI and provider UI, and then does the NPMI, um, builds whatever dependency, creates and installs the whatever dependency that is actually required for the Meshery UI. Make UI. The next command is make UI build. As the name suggests, it just builds all the Meshery UIs on your local machine. It's just npm run lane fix, yeah, and then npm run build over there. And then you next step is to actually do make server, as I showed you earlier. The make server actually just builds that and then runs the go run main.go error.go. And so once the make service actually run, you would be getting access to Meshery using on port 9081. If you want, you might actually want to select the cloud provider by navigating to 9081. There will be actually there will be actually selection for both remote as well as local. Local will be actually shown as none provider, and the remote you can actually use layer 5 itself or any other provider that you would actually want to use. So there is actually sometimes, there can be some incompatibilities. If there is actually an error page like this for Meshery development incompatibility, what you need to actually do is that you need to go to the upstream Meshery and then sync your fork with that one. Or you can actually do this remotely. You can add the upstream over here. Your origin will be actually pointing to your fork, and upstream you will be pointing to this one. If you do something like git remote -v, you should be able to see that after adding the upstream and the origin, just like this. It's just my fork. Yeah. So then you have to restart the Meshery server and then make the changes. Uh, there is actually possible. It's possible to use. You might have noticed this server config env file. Using this file, you can actually configure the log level. As with any kind of loggers, you have a hierarchy for log levels in case of Meshery, which is actually there and using Golang as well. But this is actually something which is commonly used as a good practice across languages. It's not just for Golang. So it'll be like panic level is actually panic is something which is actually say just go specific. But apart from that, fatal error, warning, info, debug entries, these are actually the log levels that you have. You can actually edit this one before running the make server to ensure that you are actually getting logs according to the level that you are actually setting. Here, by default, it is available across all the loggers, which I have seen in the past across languages. By default, it will be actually information level, and you can actually change it later. So that's about the logging. Um, Runtime configuration environments. Um, these are some of the paths that can be actually used for controlling the server behavior. Provider capabilities. If you have a capabilities.json, you can specify the path to the provider capabilities over here. And default is you can if you are not setting it, then it will be capabilities will be actually fetched from the remote provider. Skip download extensions. It actually controls whether the Meshery downloads and refreshes the provider extension packages during login or logout. If by default it is false, you can actually keep it for true if you want to actually enable that. Um, the use cases is actually like development environment. If you are actually skipping that one, uh, I mean, if you are actually skipping that one by keeping it as true, then it would make it easier while doing the development for the local server to come up easily. And there are actually write-ups about a couple of other configurations also, which would be nice to read through. And if you are actually using custom meshkit code for meshkit, yeah, meshkit is actually something which I wanted to cover about in today's meeting. There is a separate repository under Meshery called the meshkit. Um, Meshkit. This is actually like a common library or common functionality which is actually used across the Meshery components. So there is actually a good write-up about this one. This is worth reading, even though it was actually released in 2021 and it has been 5 years. It's still worth a read. I would actually add it to the chat over here. Oh yeah, Ronak had already added that. Thank you, man. Yeah. So this actually tells you about what exactly Meshkit and Meshery adapters are. So previously it was actually called as GoKit, but there is actually this microservices based based on Go, which is actually Go-Kit. So this was actually renamed to GoKit from GoKit to Meshkit, so that we actually provide the distinction. As we are actually looking into the server implementations, there are few things like error handling, for instance, which is actually handled using what is written in the mesh kit. So yeah, so that is actually what I wanted to cover in that. So it is possible to clone this repository, and in your Meshery, go mode update meshkit package. This is actually written here, but I would actually recommend that if you are actually working on the Meshery server, uh, this is this is the way I have actually categorized my folder structure. Meshery, I have cloned, I mean, I have cloned my fork for Meshery. Meshery IO is actually just the related to the website, but still to keep a proper hierarchy, I have actually used it. But it would be nice if you have Meshkit, Meshsync, and the schemas uh, in the same folder where you have the Meshery code base also um, cloned. So I will actually say why exactly we need to do that. Because if you go to Meshery, suppose you have actually made any changes in your local, and okay, let me actually do one thing here. Git status, git status, git stash. I will have to just be, I'll be just back within 1 minute because there is somebody at the door. Sorry about that. It was actually just my daughter returning from uh, playing. Yeah. Okay. So right now it's actually in sync with what we have in the head. Um, all right. So there is this go.mod file. Here you can actually see in your local also. You can actually see that the following replaces are required for local development. So in here, if you actually go further down, you can actually see that recently, I mean, just 1 day in the past 24 hours, we have actually updated Meshery schemas and Meshkit versions in our, in our master branch. I have actually pulled those changes so that those are actually in sync. Only mesh sync is actually not updated, but I prefer to have all these three in the same location so that with using this relative path, I'll be able to uh, you know uh, look at that. So stash pop. Let me actually bring my changes so that I don't have to go some this thing again. So if you look at this again, go mode, you can see that it's actually replacing the version which is actually there to this, and then mesh sync, mesh kit is also being addressed to that. And then what you can do is go to Meshery again and then use build, make build server just to ensure that it's actually working fine. So yeah, everything is actually working fine over here. So if you actually make any changes to the schemas, it'll be easier to do the local development if you have this particular folder structure in hand. Mm, So let's actually look into how to write meshkit compatible errors. I have actually told, as I have told earlier in the previous sessions as well as, uh, just a while ago. We actually tried to use Meshkit compatible errors so that error handling is, oh, no sweat. By the way, I'm sweating because it's too hot over here. Literally. So, yeah. So, while we are actually writing Meshkit compatible errors, we have to actually check for the error codes over here. This can give you an idea of what thing error code categorization and then what you have here. And in order to create a Meshery error object, you have to create a custom object. This can be this can be done using the meshkit error conventions to follow while creating errors. Error names and codes are namespace to components. They need to be unique within a component and is verified by the tool. Um, Errors cannot be reused across the components. Run make error inside code to analyze for any errors or warnings. Capitalize the first letter of every error description. Use errors.new default. If you go further down, it would help you understand how exactly an error can be defined. Let's actually go and then see that inside the code also. Mm, Meshkit errors.co. So this has a very good write-up on what exactly uh, the file is about. So these are the few conventions that should be actually taken care of while working on this. Like an error code should be defined as a constant or a variable of type string. Um, and yeah, we can actually see um, how exactly the errors.new connection error connect code. This is actually one example. The error connect code const is actually defined earlier, and then you actually have a function which returns the error using errors.new for the code, and then whether it is an alert or what type of error it is, and then you have a short description. You have a error uh, description as such. So once again, it's written. This is the way. Error code, short description, long description, and then you can actually tell uh, to the user what exactly the probable cause is and what exactly is the suggested remediation. So while you are actually designing your error codes, please keep this in mind. Uh, the fact that we might actually use technical terms, but we do not want to actually confuse the user or give a cryptic message which might actually make sense to us, but it will not actually make sense to the user. For example, an error code probable cause. I mean, you might actually say that it is not possible to acquire some log or address is already in use. If you say address is already in use uh, without specifying the port ID, I mean, the end user might not actually understand where exactly which port they are referring to or which address. Or if you actually throw up a Kubernetes is not working error, uh, just because one of the 10 checks that you used while starting the Meshery server went wrong, it might not say make sense for the user. So try to actually give brief probable cause and use brevity for suggested remediation, but it should not be like too long enough to confuse the user. Put yourself in the shoes of a user and then try to understand whether the error description that you are actually giving in probable cause and the suggestion makes sense to you as a user rather than as a contributor to Meshery. So that's one thing I wanted to highlight. So there is actually um, ongoing effect which was there to replace Logos in Meshit. There are few issues that you might be actually interested in while looking at Meshkit. And for you can actually go to the code and then from here you can actually see the release. This is the release which I was actually telling about. So a lot of changes went in to that, and it was actually bumped the mesh kit. And then inside mesh kit also we actually use uh, schemas. So when you are making some changes to schemas, you might want to actually uncomment this particular line also to ensure that your local schemas is reflected in meshkit as well as Meshery server code that you are actually using. So this is just some tips to work on how to handle this. So that's about writing error code for which is compatible with the mesh kit, whatever is there in the mesh kit. So here we will actually look at one more thing before going into the schema driven development. This is actually related to contributing to server events. So there's actually an eventing mechanism in which allows you or user to get real-time updates for processes running and the Meshery server when interacting with its endpoint. An event object is constructed using the following events: new event acted upon from user, from system, with category, with action, severity, description, metadata, and you actually use the build to get the event builder. So events is actually a package in Meshkit model events from Meshkit, which we actually just saw. Um, I think I can actually just click on here. So here, you can actually see the event severity. We saw that event.alert was actually used in the example. So these are the different types of severity that you can actually use for while creating your uh, error, custom meshkit error, meshkit compatible error while coding in the Meshery server. So this is the place where you have everything used, and this is actually implementing a builder pattern because each of this new event acted upon everything gives you a new builder uh, object on which these particular things are further invoked, and these values are actually like the fields that are actually added to the builder. I mean, you are building upon what you have actually received, and then you call the final build. So, functions are a builder class for constructing event objects, yeah. And acted upon is actually the UUID of the resource being provisioned in the server. And the events are associated with the particular, subject that is actually the resource. And from user is the UUID of the user that initiates the HTTP request. From system is actually from the running Meshery instance. Which category? You actually give the category in which the event actually falls. Uh, Say there is an example whether if it is related to the Kubernetes connection provisioning, the specified category is connection. With action, the type of action the server is actually performing. And these characters must be in snake case, and categories and actions must be in snake case. This is actually the coding convention. Uh, and event severity, you can actually see the blob inside events.go for the severity. It's a string that would actually tell the severity of the event. And if there is any severity is error, you should actually include a metadata for the key error, so that the corresponding error value is actually used in constructing that error message. And with the description, again, it is actually a detailed descriptive message. With metadata, you can actually give the data structure with supplementary information. That would be an additional knowledge for the user, without overwhelming them with the jargons in your code. And build actually gives you the event that has acted upon, and then all these values will be actually there in the encapsulated in the event. So there is actually two different types of event persistence. Yeah, they are actually persisted through two distinct mechanisms. So you can actually check for the local event storage in case of local provider, or remote event publishing is actually taken in case you are actually using a remote provider. So this provider.persist event is used for storing in the local database that you are actually having in local. Uh, in case of remote event publishing, provider.publish event to provider is actually used. So this is actually just an example. I think you can just go through the code base, and the example code over here, which tells h.config.event broadcaster. H is actually the handler over here. You get the config and event broadcaster, and then publish the event. You with the user ID over here. I mean, if you look at many of the handlers which are there in the Meshery server, you might actually see this actually. Yeah. To repositories, Meshery. Let's look into workspace handler. You can see this pattern over here. Provider.save workspace. Inside the save workspace, it might be actually funny. Yeah. So this is the way in which events are actually handled in our code base. Mm. So sending events to Meshery server. Meshery has two primary clients, the Meshery CTL and Meshery UI. Both of them actually use multiple events through the cycle. So you use something called the broadcaster for getting these client generated events and broadcasting them. There's actually a separate endpoint called API/events, where the clients can actually send HTTP post requests, and upon receiving the event, the server actually processes, validates, and broadcasts using the broadcaster. You can see the broadcaster over here, event broadcaster. Uh, uh, and this ensures that all the relevant events generated by Meshery CTL and UI are communicated and managed by the Meshery server. This is an example of send client event. It is an async function. You don't actually wait on the result as such. It's just a fire and forget. Make a new event, send the event to Meshery server using the post method. Yeah, wait. If at the end of the waiting, if the value which is actually got the response body, the status code is actually not okay, then you actually throw an error, um, and then catch console.error, use that and then send the event. So that's just one example. Um, I think it's 8:40 now. And we have one more topic, which is schema-driven development, contributing to schemas, which will be taken by Ronak. Now, over to you, Ronak. I am just stopping the share here. Yeah.
Um, yeah, thanks, Kavita, for that wonderful information and walkthrough about Meshery schema, server. So, we'll be learning about schema-driven development and what exactly it is. So, this is our Meshery schemas repository, and schemas are the single source of truth that we have defined over here. And as a project, Meshery has different types of for example, designs and so models and etc. So we have each of them has some logical constructs that are defined in mystery schemas, and they are used by different API endpoints. For example, if I have to interact with mystery server, so there is a request has been sent to the mystery server. So that request has a certain struct or a logical construct. So for that, the construct that has been imported, it's imported from the Meshery schemas repository, and it's uniformly used by the Meshery cloud as well and other repositories as a single source of truth. So uh, a repository or an endpoint is considered schema driven when all of its constructs are defined in this repository and they are being reused in the API endpoints. So I'll be just walking through with some of the schemas that it's defined in the defined over here. Uh, so these are the versions of all of the endpoints, the previous versions of the schemas. Alpha 1, Alpha 2, V1, Alpha 3, and they are um, named according to the K8 style. So we have currently also released the latest one, that is V1 Beta 2. So for example, if we go to any of the versions and the api.yaml file is the open API specification index file that we have. So for example, we have defined the API path over here, and then we define the request and response. So we'll be talking more about it, but this is how the structure of it looks like. In each of the versions, we have different types of APIs grouped by their categories or resource. And then we have something called as a templates folder where um, anyone can directly refer how a schema object looks like so that they can, if they want to make their own object. And we also have, it's divided into two files. One is api.yaml and one is the academy.yaml, for example, in this academy folder. So we'll be first more talking about what exactly is Open API. So it's a standard format for your for describing your RESTful APIs that is written in YAML or JSON. It's not a code, so it's a description of your API, what paths exist and what parameters and what exactly do they return and what errors they can produce, for example. And so in the Open API specification file, you also define a version of it over here. And these version numbers matter because they have some features that differ between them. So here's an example of a simple Open API specification document. we define the version of the Open API spec, and then some information like the metadata information, title, and version. Then we have defined slash hello. So this is the API endpoint for which this schema will be used. And this is the slash hello, and this is the operation or the method, that is get method over here. And we have a summary that says hello. So it has a response that has an code 200. And over here we have defined the content, that what it would be returning. So it's a JSON response. Um, and the what exactly it's returning is a message of type string. So this is how we define in the Open API specification for each of the endpoints what exactly it would be having a request and response structure. And this is moving on to another topic, that's the anatomy of an Open API document. So this is the Open API version that we have already. Yeah. uh, and there's the schema version, and the paths contain the all the endpoints that have been defined the same way we have defined in the Meshery schemas repository. And over here, a new term that you may encounter is a component, that are some reusable pieces of subschemas that live over here, and some data shape definition. Another thing, so for example, over here, there are four main sections. That is info, that contains metadata, title, version, uh, and things like that. The version of the schema, not the OpenAPI version. So this is the OpenAPI version, and this version is the version of that schema, alpha 1, beta 1, and things like that. And paths is every endpoint uh, is defined over here. And component slash schemas is the data shape of what exactly the object should look like. And we have some reusable parameters and responses. So you may, if you go to any of the constructs in schemas, so you may encounter something called as a reference, and it says hash component schemas and a path to it. So what exactly is dollar reference? So it means that it replaced this line with the content from that location. So for example, if I have reference, so we are referencing another type of schema over here, that is user. And since it's like written like slash sorry, hash and component schemas user. So it means that this is in the same file. It's called a same file reference. So everything after hash is the path inside that file, starting from the root. So for example, if we try to search over here this, so in the components block, uh, we have schemas, and then schemas we have academy, curriculum, list, response. So that is being referenced over here so that we don't need to redefine it again and again. And this hash reference is also can be used for cross file reference. For example, here we are going up for two directories, and then in another version in the core api.yaml, so this is over hash and then components response 400. So in that file, in the api.yaml file, go to the root and see the components block, then see the response block, and then see this error code 400. So that's how this reference thing works. And we can also have this reference in a cross repository reference. So this was a cross file reference. Then that's another level, something called as cross repository reference, where we directly go to the from GitHub, we directly fetch the file and GitHub user content.com, and in Meshery schemas, it's master branch. We can find the api.yaml and then go to the components block schemas user. So that's how, if we want to um, refer our schema from cross repository, we can follow this kind of a thing. And this is how the Meshery Cloud documentation references the user shape in Meshery schemas without having to duplicate it. Um, so moving on to another problem. So for example, if we navigate to the Meshery server repository in the Meshery, so we can see some of the routes that are defined over here. And these are all the API endpoints that Meshery server consumes. So it has irrelevant to the API endpoint. It has its own handler over here, which you can find in the handlers section. So for example, if I just demonstrate any of the handlers, so this is a get request to slash API slash model slash category, and it gets all the mesh model categories for a given name. So over here, we try to get the response and destructure it with using models dot mesh model categories API response. So as you can see in the Meshery server, it has its own struct construct defined, and it's not using the construct that is coming from the Meshery schemas. So this is what this behavior it's ideally it should not be. So all of the Meshery server API endpoints should refer the single source of truth, that is the Meshery schemas repository for all of these constructs. So I'll be showing you how this API.yaml file also converts to Go constructs that we can import in Meshery server. So for example, this is one of the folders that the models one that any contributor shouldn't touch. So since it gets auto-generated via a workflow on a recurring basis. So for example, we can see the V1 beta 2 and over here. So these are the Go structs that get generated from the same YAML file that I demonstrated previously, the api.yaml. And these constructs over here or these types, these gets imported to the Meshery server. So some of the work over here is going around um, to make sure that we have a single source of truth, Meshery schemas, and all the API endpoints constructs are defined in Meshery schema. And we don't have any of the local constructs in Meshery server. So this is what it looks like. And moving on to, it also has something like helpers.co, and this is generated by OpenAPI CodeGen from this YAML file. So over here, so the api.yaml file that we have seen, so it has three roles that it references all subschemas through that hash reference, and it aggregates all references via this thing, and it defines all the API endpoints which contain the REST operations get, post, put, and delete, and it acts as an entry point. This is what I was talking about. It acts as an entry point used by code generators, that is OOPI code gen, and similar for TypeScript. So this file over here that we have in any of the resource api.yaml. So this serves as an entry point, and here we have defined all the API endpoints with its relevant method over here. And then there are certain tools like OpenAPI CodeGen that generate Go structures out of this file that gets generated on a recurring basis. And they are talking about another file that you can find that, for example, academy.yaml. So this adds the sub schemas defined that is referenced from api.yaml file. So uh, the APIs are defined over here and it's being referenced in academy.yaml or similar thing we have for connections, for example. So this is a common structure that we follow for each of the resource. Um, so this YAML file defines the contract over here of all of our schemas. And there's one thing as well that differentiates the Meshery server and cloud API endpoints is a X internal tag over here or annotation that we define. For example, to any of the API endpoints, if it has an X internal with a cloud name, that means this endpoint is consumed by Meshery Cloud. And since some of the endpoints are overlapped in or are same for the Meshery server and Meshery Cloud, so they don't have an X internal tag. So for the APIs that don't have an X internal tag, they are used by both Meshery server and Meshery Cloud. Or if it does have a X internal tag for X internal tag, something called as Meshery, then it's just consumed by Meshery server. This thing is also documented in the README, for example. So you can go through it as well. Yeah, so with X internal, it's included in the respective client, example X Cloud. And if X internal is not defined, it's included in both of the clients. Um, so I'll be showing a little bit of walkthrough of how you can build the schemas repo. So if you just clone this on your local machine, the Meshery schemas, and then you write make build. So it will first validate your schemas so that we don't have any blocking violations through this script validate schemas.js. And you can also find another make target that does only this thing, that is make audit or yeah, audit schemas, so that the schemas are in placed over here. And then it will start generating all the Go files from that api.yaml, and that's the entry point. And in the models, we can see the Go structures that are ready to be reused in other Meshery server and Meshery Cloud repositories are generated. And this thing, as I mentioned, it happens on a recurring basis in the Meshery schemas repo. And similarly, we have some TypeScript interfaces for schemas that are defined over here as well. So it just it says build success, and there's another make target that I want to demonstrate. That is, I just basically stopped the build to show another make target, but it is almost a success over here. So it says make bundle open API. So it will generate uh in the root of the project, it will generate underscore open API build that have three YAMLs files, one for cloud API endpoints and one for Meshery server API endpoints, and the other one for the that is the merged API endpoints file that contains both of the Meshery server and Meshery cloud API endpoints. For example, this is the same file. Um, that is the OpenAPI spec, and it has all its cloud API endpoint schema defined. And this file is for the Meshery server, and this is the merged OpenAPI.yaml. This also gets published to layer 5 docs and Meshery docs on a recurring basis. And it has all the API endpoints defined for Meshery Cloud and Meshery Server. So and it also has the constructs over here. Another useful make target is the Meshery schemas versions. So for example, if you want to find, so since this is going from a long time, you can also find the versions that we have for each of our schemas grouped by resource. For example, Academy schemas, we have two versions till now. For batch, we have only beta 1. And if there's another make target in addition to that, that will help you find what is the latest version for each of the schemas. So this make schemas versions latest will give you the latest version for any of the schemas, B1 beta 1 for user. Similarly for token, we have B1 beta 2. So you can play around with some of the make targets that we have in this, and you can also explore all the make targets by just running make command. We have a couple of them. You can validate the schemas with validate schemas. So no blocking violations found. And similarly, we have schemas for TypeScripts as well. And there's another best practices and documentation that is also written how you can contribute to Meshery schemas. So I can also share this in the chat. And yeah, I think we are over time. Do we have anything else to cover, Kavita?
I don't think we have anything else to cover. Good that we didn't actually start with the CI because it would have gone for another 1 hour because there are a lot of
Yeah.
things to cover with that, respect to that. Um, I think in the next session we would be actually covering the Meshery CI and then followed by the fun quiz that we usually have at the end of each of the units. Um, if any of you have any questions, this is the right time to ask, I think. We'll wait for just 2 or 3 minutes before wrapping up this session. Yeah.
Hi Ronak. I was trying to understand Mesri schema, but uh, how they define infrastructure, I am a bit confused about that, and how they differ from the database schema like MongoDB and others. Can you clarify that?
Yeah. So in MongoDB as well, we have data models, and that's what schemas mean as well. So there, here, this is for the API endpoints. So you can read more about the Open API specification and how it defines endpoints. So a little example that I demonstrated previously as well. For example, this is this path, that is this endpoint, and over here we are defining the response structure of how it looks like. So it says that the response should be in JSON format, and the schema that is used is being referenced over here, that is component schemas and mesh models page. So it means from the root of this file, you can find this mesh models page. And yeah, this thing over here. So it has defined over here that okay, this is a type object. It has a field called as a page, which is of type integer. The minimum value should be 0. Same thing we do in other uh, models if we want to define a schema for a model, for example, in MongoDB. But this is for the API endpoints. I hope that answers your question. Okay, I thought I was mute.
I
We
think
can't hear. Yeah, yeah. Okay.
I think we cannot hear Virat if you're actually speaking.
Yeah.
Yeah, I understood a message in the chat.
Okay. I encourage if you can read the schemas documentation, that would be, and play with some of the make targets, you will get a hang around it of how it's working. Do we have any more questions?
Just one question. The previous videos, the sessions, where I can find them, those were also recorded, right? If I'm not wrong.
Yeah.
So, is there any
Yeah,
way to get them
all of
or in the
them are
YouTube?
recorded. So yeah, you can find in the Meshery YouTube channel.
Okay, I went there,
This
but
one over here.
okay, got it. March
Okay, so
18th and
yeah.
January, but I actually went there at the very beginning, but couldn't find exactly. Is this in some playlist or
Um, it's not currently structured in any playlist, but you can go to
okay?
the live section over here since all of
Okay.
the
Oh,
recordings were
got it.
live. So you'll be
Got
find
it.
them pretty
Yes.
recently. So don't
Yes, then
navigate
I got it. I
the
got it.
home or yeah.
Yeah. Yeah. Thank you.
Yeah. Thank you. I think we don't have any questions left. So uh any closing thoughts, Kavita?
Mm. Nothing as such. We are anyway 6 minutes over time. So we can actually wrap up and then meet you all in the next session next week, where we will be covering the Meshery CI, as well as we would be having a fun quiz at the end for the end of unit, so that it would help you supplement you with kind of questions that you can actually expect in the real Meshery, certified Meshery contributor test. Yeah. Have a nice weekend and let's see you on next Friday.
Yeah.
Bye.
Yeah.
Uh
Thank
Thanks for
you.
joining everyone.
Thank
Bye.
you.
Thank
Thanks
you.
Bye.
both Raunak
Thank
and
you,
Kavita.
everyone.
Bye.
Thank you.